The presence of the Romaine hydropower complex changes the river's flow regime. Hydro-Québec is committed to conduct environmental follow-ups until 2040 to monitor changes in the environment and to assess the effectiveness of mitigation and compensation measures. The follow-up includes a study of the water column at the mouth of the Rivière Romaine.
The water column could influence soft-shell clam and eelgrass communities. The water column is the mass of water circulating above soft-shell clam and eelgrass habitats. The thickness of water in the column varies according to tides, winds, waves, and storms. We'll track this variation in water thickness and how it influences soft-shell clam and eelgrass by measuring the water salinity and temperature. The study area for the water column is the mouth and bay of the Romaine. We'll compare it with control environments that aren't affected by the Romaine. These are the bays of Mingan, Trilobit, Nickerson, and Victor. We compare the water column spatially and over time, before and after the development of the Romaine complex. In monitoring the water column, we'll especially be looking at temperature and salinity, how variations in the water mass affect soft-shell clam and eelgrass. We monitor these variables in two ways. We set up mooring sites at different locations in the control bays and in the Bay of the Romaine. We attach an instrument to a buoy to measure the salinity and surface temperature. Another instrument is attached to a metal structure on the ocean floor. We've set up 9 mooring sites, 5 in the Bay of the Romaine and 4 in the control area. The instruments will take readings every 20 minutes for 4 months, from early May to late October. We use all that data to characterize the habitats of soft-shell clam and eelgrass, or at least the mass of water above those habitats. For example, when the tide rises, the temperature drops and salinity increases. When the tide falls, the reverse happens. The salinity drops and the temperature rises. Since our study area is relatively large, we can't set up mooring sites with instruments everywhere. So we combine these mooring sites with spot measurement stations. We travel by boat with the same instruments, which we drop down the water column to measure the salinity and temperature from top to bottom. We travel across the bay according to the tides and time of year. We can use all that data to reconstitute what is happening in terms of salinity and temperature. We can represent this data in different ways. One way is to map the distribution of temperature and salinity. For example, what is the temperature distribution at high tide? We'll map the distributions for temperature and salinity and do the same at low tide. Then we'll compare low tides according to the seasons. We can also look at average readings for a specific buoy or location and compare that data with different periods during the year. We'll be able to see whether there are changes following the impounding of the Romaine complex. Our data to date shows very little difference in terms of temperature and salinity distribution in the mouth of the Romaine. There is also little seasonal variation in temperature and salinity. And there is no difference between what we're seeing at the mouth of the Romaine and in the control areas. The small variations in water temperature and salinity are mainly related to coastal conditions such as waves, storms, and tides, and the large volume of water coming from the St. Lawrence, compared to the small volume of water from the Rivière Romaine. The results confirm the predictions of our 2007 impact assessment. The results from our follow-ups over the next few years will add to these findings.